Welcome to Chillin' 101. We hope this video helps.
You start by removing the battery and props, safety first. Once done, ground yourself with an ESD strap and photograph the board to preserve wiring and connector locations. Use a multimeter to check continuity on power rails. This tells you whether traces or pads are open. Then inspect for burnt components, lifted pads, or corrosion. These are the usual suspects. If a component looks damaged, mark it and fetch the service manual or schematic so you know the exact replacement value and orientation. You now focus on isolating faults. Probe VCC, ground, and sensor buses while the board is unpowered and again briefly on power to spot voltage drops. Once identified, heat and remove the faulty part. Use a soldering iron at 3040W plus wick or a pump, then clean the pad area with 90% plus isopropyl. Make sure replacement parts match voltage, package, and polarity. Place them carefully and solder with minimal dwell time to avoid lifting pads. After repair, secure connectors and reflow suspicious joints. You finish by powering the controller through a current-limited supply, monitor for heat or abnormal draw, stop immediately if you see smoke or rising current. Once stable, reflash the correct firmware and run sensor calibrations so accelerometers and gyros report expected values. Make sure UART and I2C buses enumerate peripherals. Test motors on a secured bench, not on the airframe. If intermittent issues persist, check soldered joints with a magnifier and use logging to capture errors. This often reveals timing or communication faults.
Thanks for watching. Consider subscribing if we helped you.